Tuesday, of course, is our midterm, number 2. I know I'm repeating myself. You can have one sheet of notes, two-sided. You can use a calculator. If you don't have a calculator, I will bring a bunch of calculators. You can borrow. They're all going to be this, kind of fancy TI. So if you're not familiar with these, either find out or come see me Tuesday before class. We can go over it. Like regular calculators, you can be 5 plus 3 times whatever. This thing you can actually type in a whole formula, before you get the answer. So it's actually easier to use. No cell phones or computers. We're going to go over a new subject today, and I recommend that you focus on the previous material till Tuesday. The homework's listed as due Thursday, but if you don't have time, I'd rather you focus on the midterm, turn the homework in late. There's no deduction for that. And today we're going to, this is section 9.5 in the book, radical equations. These are not equations used by radicals of the 60s, but rather equations that have maybe a radical symbol, or, as we saw last time, square root of x can be written x to the 1/2 power. I guess in algebra we learn how to solve a lot of different kinds of equations. And I guess I should make clear that we're not talking about something like this, like x plus the square root of 3 equals 4. I mean, here there's a radical, but it's just a number. So, we solve this the same way we would solve any equation. That would be that. What we're talking about is equations where the variable might be under the radical sign. This is not going to be that different from the other kinds of equation solving we've done. However, there are two things to keep in mind. Number one, we need to remove the radical. We're going to go over how we do that. The second thing to keep in mind is be careful that the solutions are real. This is actually one of the primary issues with these. going to talk about this quite a bit. But just to introduce what I mean by this, let me show you something that, I don't know, it's kind of like reverse magic. It's not really magical, it's unmagical. I say negative 8 equals 8. This is a false statement. It's not true. But if I square both sides of this equation, I get 64 equals 64. That's a true statement. And that's really at the heart of this. We're going to solve things, and we might end up looking like we have something that's true, when in fact it's false. So the way we deal with this is after we've solved an equation, we go back and we check that the solution actually works. All right. Let's start with a simple equation. Square root of x minus 8 equals 0. Now, in solving equations with an x, right, we want to isolate the x, and we want to end up down here with this equation x equals some number. So I think it's pretty straightforward. Just like if it was x minus 8, we're going to add x to both. We're going to add 8 to both sides. And we're going to get the square root of x equals 8. And at this point, remember, we have to remove the radical. So the way we remove the radical is we're going to square both sides. Okay. Well, the square root of x squared should normally be x, and 8 squared is 64. And it looks like 64 is going to be our solution. But before we jump to that conclusion with this kind of equation, we have to check. We have to plug it back in and see if it actually works. So we take a look, 64, square root of 64 minus 8, that's supposed to equal 0. Square root of 64 is 8, minus 8 equals 0, 0 equals 0. Good, it's a true statement. So now we know it actually is a solution. All right. Let's see an example where this doesn't work out so well. Square root of 3x plus 6 equals 0. Right? Just use the same technique. Square root of 3x equals, square root of 3x minus 6 on both sides. Minus 6, okay. Well, again, to get rid of this radical, I'm going to square both sides. And here, this is just going to be 3x equals negative 6 squared is 36. X divided by 3 is 12, okay? So far so good, but as I said, we have to check. So let's take a look. 3, square root of 3 times 12 plus 6 equals 0. This is the square root of 36 plus 6 equals 0. Square root of 36 is 6, plus 6 equals 0. You can see this clearly, it's a false statement. So 12 is not a solution. And in fact, there are no solutions. What does that mean? Well, if I were to make this into a function, y equals square root of 3x plus 6, and I was to graph it, I might look for where the y is equal to 0, because that's what I want. And I would find my graph would look something like, let's start at 6 and it would go like this. So you can see, this is the graph of this function, but it never goes down to x equals 0, or I'm sorry, y equals 0 down here. Never reaches down. So there are no solutions. And again, that's what you have to look out for when solving a radical equation. Okay. I feel like I should leave this up. Maybe just move it over here. One, remove radical. 2, I'm just going to write check. Okay. All right, this is a little different kind of problem. Because instead of a square root, I'm going to have a cube root. But again, I'm going to have a variable into the radical. There's my equation. Okay, I'm just going to go, headlong into the breach here. I want to add 2 to both sides. So I get the cube root of 2x plus 1 equals 5. Well, anyone have any ideas how I might get rid of this cube root radical? Thoughts? Yeah, okay. Let's try that. I'm going to kind of do it in place here, save a little room. Well, the cube root cubed is just going to be 2x plus 1. Does anyone know what 5 cubed is off the top of their head? That's a good number to know. 5 squared is 25, and cubed is only 25. It's just easier to remember than a lot of things like that. Okay, I'll keep going. Subtract. Now I can subtract 1 from both sides. And I'm going to divide by 2. I'm going to get my answer 62. But am I done? Okay, I saw. I'm happy I saw head shake in the right and wrong direction. Yes, I'm not done. I need to check to make sure this is a valid solution. So let's write this out. Cube root. This is so important that I'm going to repeat it for AJ. We're doing radical equations for which there are 2 important things that are different from regular solving. We need to remove the radical, and we need to check the answer, because the answer may not always be valid. And that's what we're doing here. We just did a problem, and we're checking. Okay, so 2 times 62 plus 1 minus 2 equals 3. Right? Cube root of 124 4 plus 1 minus 2 equals 3. Cube root of 125 minus 2 equals 3. And this is the point where knowing that 5 cubed is 125 comes in handy, because now I know I can do it on the calculator. This is just 5 minus 2 equals 3. 3 equals 3. Check. So that tells me this is a valid solution to this equation. Okay. That doesn't cover everything. Covers almost everything. Sometimes we have an equation with radicals where we have more than one radical. Okay, I know we got a sharp audience here. Does anyone have any thoughts on how we might get rid of these radicals? Yes?
Square both sides.
Square both sides, yeah. Why not? All right. Squared. 5x plus 1 equals x plus 11. Subtract x from both sides. And I subtract 1 from both sides. And I divide by 4. So 10/4 is 5/2. But of course, I'm not done. Right? I need to go back and check my original equation. See if this is a valid solution. All right, square root of 5 times 5/2 plus 1 equals square root of 5/2 plus 11. All right, need to do a little math here. 5 times 5/2 is 25/2 plus 2/2. That's going to equal square root of 27/2. Over here, again, 5/2 plus 22 over, wait a minute, yeah. 11 is 22 over 2. And this equals square root of 27/2. All right. So that works. So now we know this is a valid solution. All right. These can get progressively more complicated and more difficult. Let's take a look at here now. We have one with a 4th root. 3x plus 4th root of 2x minus 5 equals 0. Anyone have any ideas on how I might get rid of these radicals? If I could get it to look like this, then I'd have a chance, wouldn't I? I could do by subtracting either of these from both sides. Let's do that. Let's subtract the 4th root of 3x from both sides. So we get the 4th root of 2x minus 5 equals minus the 4th root of 3x. And then by now, you know, we just raise these to the fourth power. This is going to be 2x minus 5. The fourth power of minus 1 is just 1. Negative 1 times negative 1. There's negative 1 times negative 1 is just 1. And that'll, the fourth root of 3x to the fourth is just 3x. Right, so I subtract 2x from both sides, and I get x equals minus 5. Of course, I'm not done yet. I have to see what happens here. Well, I can see I already have a problem. 3 times negative 5 is negative 15. And that's not even a real number. So I already know that this is, this is not going to be any good. All right, any questions? Once you kind of get the hang of it, it's very, most of it is just the same old stuff you've been doing. Yes?
So when you get an answer where there's like no solution, when you get an answer that's no solution, you just write no solution? Is that what you
Oh,
on the test or like on the
I
side?
would say, I would exactly what I would write. I would just say, I have a name for these, not everybody uses this. I call these phantom solutions. They're not real, they're just, they're like ghosts. When you look at them, they disappear. You do get them, right? We have a process for solving equations and you get a solution, but with radicals, you can end up with something that's not really a solution. Okay. There's another technique for certain kinds of problems. So far, what we've seen is we've had a radical or two radicals that disappear when we raise it to a power. We might see a problem like this though. Now, we could put this by itself. Yeah, we could do it either way. We can say square root of x equals x minus 2. Yeah, this is fine. And then, of course, we're going to square both sides, right? So here we get x equals, we want to recall, remember we got a pattern, x plus a plus b or a minus b squared. Remember the pattern? This might be something good to put on your note paper. A squared minus 2ab plus b squared can come in handy. Or we could FOIL it. We could, x minus 2 times x minus 2, we could FOIL it. We get x squared. The first, the last is minus 2 times minus 2 is 4. Minus 2x plus minus 2x minus 4x. Okay? Right. Right, we're doing good. Now, let's subtract this x. I'm going to switch this around too. Let me do that first. And I'm going to subtract x from both sides. All right. Seems to have gotten me in a pickle. followed my intuition here. I'm gonna have to start over. It's this is going nowhere fast here, I think. But, you know, that happens in math, you know. Sometimes you go down a dark alley and it is the wrong alley. Let me try it again. So I had this equation, square root of x plus 2 equals x. Okay. Well, the other strategy looks like this. I want to do a substitution that will get rid of that radical. So I say y equals the square root of x, which means that y squared equals x. Okay, so that transforms this equation kind of nice. You get y plus 2 equals y squared. And again, I want to move everything to one side. So minus y squared plus y plus 2 equals 0, or since I'd rather not have a minus here, I'll multiply through by minus 1. All right. I made a mistake again. Gosh. How's that? Oh. There we go. Okay. Let's try and reverse FOIL this. I think this can only be 2 and this can only be 1. So I'm looking at this. Can you tell me what the signs that go here and here are?
Plus and minus. Plus and minus.
Definitely plus and minus, because this is minus. I guess the question is, where does the minus go? In front of the 2 or in front of the 1?
In front of the 2.
In front of the 2, yeah. Okay, all right. Well, this got me to where I want to go here. So this tells me the solutions are what? Y equals -1, or y equals 2. Wait a minute. Y is the square root of x. Right? I want to find x. I don't really want to find y. So if I want to find x, I have to find y squared. So y squared here equals 1, and y squared here equals 4. You're right. So I have two possible x's. X equals 1, x equals 4. But because I was dealing with radicals, we got to check. So let's check 4 first. Square root of 4 plus 2 equals 4. Well, square root of 4 is 2. Plus 2 equals 4. 4 equals 4, yes. Solution. Now let's try the other one. Square root of 1 plus 2 equals 1. 1 1 plus 2 equals 1, or 3 equals 1, which of course is clearly a false statement. No, not a solution, so we have to eliminate this. You see how these phantom solutions, they just kind of pop in out of nowhere. And they're not solutions, they just came out of our process. This might give you like a little wonder about mathematics. Does it really work if it's giving us the wrong solutions? Well, if you look at why this is the wrong solution, then you can kind of go, oh, okay, now I understand, you know, it does kind of make sense. Again, whenever we square something, remember what I started with? If I take a false statement, and now I square both sides, I get 64 equals 64, I get a true statement. And that's where these phantoms come out of. All right. Any questions on this? Again, I kind of recommend you put off homework for any of, this week till after the midterm, focus on the midterm. So we have a few more minutes, and what I'm going to do is, if anyone has any kind of questions about the midterm, any kind of problems you'd like me to go over, I can do that. If you feel you're ready for it, leave early. It's up to you. I'm happy to hang around till we're done. So, yes.
How many questions?
Okay, I'm going to answer your question. I'm going to tell you how many questions there will be. But I want you to realize some of the questions will be really easy. Some of them will take a little more work, some balance, and there probably will be 20 questions, just like the first midterm. All right? It's not actually a math question, but that's acceptable. Yes?
Does it covers as far back as the factoring we started right for the first midterm, right?
You're asking like how far into the class? The exam will not cover anything today or Tuesday.
Okay.
Is that the answer? Okay. It could, anything all the way back to the beginning of the class is fair game.
Okay.
But that's just because you're going to need it. You certainly need that for the final. But we'll focus mostly on things. Yes, AJ?
Well, are you able to go over that domain one more time, like the facts problem?
I got white noise here and you're wearing the mask. You just have to speak up.
Could you go over domain one more time, that one practice problem?
Okay, I heard you want me to go over something that I...
Domain?
Domain.
Oh, domain. Oh, of course. Domain and range. Okay. So I could have some function. I'll just put a few different functions up. Like I could have x squared plus 3, or I could have x minus 2 over x minus 1. I could have a function. And a function actually includes a domain. A function is not a function without a domain. Sometimes I could state the domain. Like I could state the domain of this function is the interval 0 to 2, right? So a domain is part of a function. But usually when a question is about what's the domain, what we're asking is, I haven't told you what the domain is. And so you want to tell me, well, what could the domain be? And by default, we want it to be as much of the real numbers as possible. All right? So in the case of this function, I can put any real number in here. 0, 5, negative pi, you know, a billion, right? So for here, the domain is, you could just say all real numbers. Another way to write that is the interval from negative infinity to infinity. Okay, so if I just show you a function, and I haven't said what the domain is, you have to look at it and see what's the maximum it could be. Now for this function, it's a little different. I can put in almost every real number. It's almost all real numbers, except what? What can I put in that function?
Or one.
Right. You got to be careful. -1 is fine. -1 minus 1 is -2. But you can't put 1 in because we can't divide by 0. Here's another example. Different. Say f of x equals square root of x, or 2x plus 3. Say, what's the domain? Well, what's the problem here? I can't put something under the radical that's negative. So here's how I would go about this. I would say 2x plus 3 has to be greater than or equal to 0. Now actually, if I ask what's the domain and you just wrote that, I would have to go, that kind of does it, you know. But we could do a little more. We could say 2x is greater than or equal to -3, or x is greater than or equal to -3/2. That would be kind of a more elegant answer. So all real numbers where x is greater than or equal to -3/2. We won't do this in class, but you know, somewhere they might say here, draw a line. 1, 2, -1, -2. There's -3/2. Let's graph it. Okay, that's the graph of the domain of this function. Now, you could have a problem which is similar, but is more complicated, right? You could have, well, I'll make it simple in a way. F of x equals square root of 2x plus 3 over x minus 1. Well, now it's kind of the same answer as this question, except you also have to say, and not 1. Right? So the domain is, you know, when you ask that question, it's just, what's the maximum domain? Or alternatively, what do I have to exclude? All right. Is that good?
Yeah.
Okay. Anything? Anybody have any other questions? Yes.
How do you factor a trinomial using the quadratic formula?
How to factor a trinomial. Okay, maybe it's the language. A trinomial is also what we would call a quadratic, right? So, quadratic expression. So if I said x squared plus I have to think now. 3x plus 2. It's a nice simple one. So what we've learned so far is how to use reverse FOIL. So I look at this, I see, okay, it's x squared, so there's going to be an x here and an x here. And This isn't guaranteed to work, but I hope it'll work. What can I see? I've got a positive 2 here. So it's got to be 2 and 1. And they're both pluses. So let's see if that works. The firsts give me x squared. The lasts give me 2. The inner and the outer, 1x and 2x is 3x. So okay, that's a really simple example. Now, if instead I had something like this, say 2x squared minus 8x plus 8. There we go. Well, okay, that's a little harder. For something like this, it's always good if you see that there's a common factor, which there is here, 2, to get that out of there. Now, we can do this with reverse FOIL. The complication here is, now I've got 4, I have to look at 2 things, right? I have to look at 2 and 2, and I have, or 4 and 1. That's kind of the reverse FOIL process. The other thing you can do with something like this is if you're really good at pattern matching, and remember that pattern we talked about, a minus b squared equals a squared minus 2ab plus b squared. And then you look at this and you go, wait a minute, if a is x, b is 2, 2 squared is, negative 2 squared is 4, and negative 2ab is negative 4x. So this is just x minus 2 squared. Again, I think I put them on that sheet. This is really good to know. A plus b squared, a squared plus 2ab plus b squared. And the other really important pattern is a squared minus b squared, not to be confused with a minus b squared. This is a plus b times a minus b. Really useful pattern. So, that's, factoring a trinomial, I guess I should add, factoring a trinomial that can be factored this way. Now, some trinomials won't factor easily, and we're going to learn another technique later. Oh, Michelle, you forgot to mention, but that's okay, it wasn't your responsibility. I want you to know something about an error on the, someone have the sheet? The review sheet? Yeah. There's something I put on there that I shouldn't have.
I don't know.
Well, Michelle's going to pull it out for us.
I don't see the 15.
15. No. Yes.
Yeah.
Yeah, number 15. How to find the roots of a quadratic equation.
Won't be on the
No, that's not the right one. Okay, number 18. How to factor a trinomial using the quadratic formula. We really haven't gone over the quadratic formula. If you know how to use the quadratic formula and there's a problem where you can't, of course you're allowed to. But do not expect some hard problem where you need to know the quadratic formula. All right? Thank you. Okay. While you're thinking of questions, I'm going to erase. Anything else? If during your studying you hit something and you're panicked because you go, oh, I don't know how to do this, or I don't know what you're talking about, you can email me over the weekend. Really, really important, we can do Zoom. But I'll also be in my office hours Tuesday before class. You can come by and ask if you're worried about something. Okay.